Hello friends, in this class we will discuss about electrode potential. Electrode potential. Now dear friends, before this topic electrode potential, we have discussed about electrochemical cell, when it connected with the external source of battery, what will happen, and ultimately we have concluded that the cell used to flow current, means the cell generally used to produce or to use the reaction involved in it to supply current. But we know that current belongs to potential. The first and foremost thing is that, and current will be only due to the difference in the potential. So the potential comes, and the potential, when the word potential comes, means the potential related to cell, and it means there is a cell potential, and cell is constructed by the electrodes. It means that is depends on the electrode potential. So we have to understand what is the meaning of electrode potential, and we know that there are two types of electrode. One is anode, another is cathode, and in both there will be potential. How this potential generates? Look at here. Suppose in the first case we have an electrode which dipped in electrolytic solution, in this manner. Suppose this is zinc electrode, so this will be dipped in the zinc sulfate electron. We know that when the zinc is working as anode, it proceeds oxidation. Because this is the general theory, or we have already explained that at anode oxidation occurs. So when oxidation means loss of electron, so the first thing is that zinc loss electron convert into Zn2 plus and loss 2 electrons. So as soon as the zinc lost 2 electrons, the electrons accumulate on the surface of this zinc electrode, and the positive ions enters into the electrolytic solution. So we can observe that at the surface of electrode there is a highly negative charge, and in the solution there is highly positive charge. So due to the difference in the charge, there will be the difference in the potential. So due to the difference of potential at metal electrode surface and its electrolytic solution, it creates potential difference, and this potential difference is known as electrode potential in the case when an electrode work as an anode. In the same case, when we apply in so when we apply the same concept with the cathode, suppose this is made of copper, and we know that copper generally works as an cathode, and this is dipped in the copper sulfate. Again at cathode reduction proceed, and in the reduction the Cu2 plus ion gains 2 electron and convert into Cu atom. Now Cu2 plus ion from solution gets electron and deposited in the form of solid on this metal surface. So the electron has been captured in the electrolytic solution and the neutral atom deposited on this surface. So again there is a potential difference at the surface of metal electrode and its electrolytic solution. Such type of difference creates in potential difference, and that is known as electrode potential. So in this manner, at individual electrode the potential difference generate, and that is known as electrode potential. So there are two types of potential. First is types of electrode potential. Types of electrode potential. The symbol for the electrode potential is E electrode. That means electrode potential. And there are two types of electrode potential. First is oxidation potential and second is reduction potential. When we will consider oxidation potential, when that electrode work as an anode. When we consider reduction potential, when an electrode behave like cathode, in that situation we will consider reduction potential. And for a same type of electrode, means suppose we use here zinc electrode as an anode here, suppose in some of the cases zinc is working as a cathode, in that condition its oxidation potential and reduction potential will be equal in magnitude, but their signs will be changed. Just for an example, for zinc, when zinc is working as an anode, the zinc oxidation potential is 0.71 volt when it is working as an oxidation potential anode. If it is working as a cathode, its reduction potential will be here minus 0.71 volt. Sorry, this is 0.76, minus 0.76 when it work as a cathode. Okay, so the magnitude of oxidation and reduction potential is same, but its sign is totally different. Okay, otherwise there is no difference in the oxidation potential and reduction potential. This is the concept of electrode potential. Now, in the same way, the another term we use here, that is standard electrode potential. Standard electrode potential. The meaning of standard electrode potential, standard electrode potential. Standard electrode potential. The symbol of standard electrode potential is E naught electrode, E standard electrode. What is the meaning or concept of standard electrode potential? The potential of an electrode when temperature is 298 Kelvin, pressure is 1 bar, and concentration of electrolyte solution is 1 molar. In all these three conditions, that electrode potential is known as standard electrode potential. Just for example, E standard zinc Zn Zn2 plus. This is oxidation potential because zinc is converting into Zn2 plus. This is standard electrode potential of zinc electrode. If I write here like this, Zn2 plus Zn. Again, this is the standard electrode potential of zinc electrode when it work as a reduction potential or as a cathode. Maybe in actual concept, this is oxidation potential of zinc, this is reduction potential of zinc, but at the standard condition. In the same way, if somebody has mentioned Cu2 plus oblique Cu, that means this is the standard electrode potential of copper electrode in reduction manner. If we want to express this into oxidation, it will be here E standard Cu oblique Cu2 plus. So meaning is that when we determine the reduction potential of any electrode in all these three conditions, temperature should be 298 Kelvin, pressure should be 1 bar pressure, and the concentration of electrolytic solution must be 1 molar. At that condition, that electrode potential is known as standard electrode potential. Now, after standard electrode potential, the next thing is that Sol and cell potential. Simple meaning, cell potential means the potential difference between the two electrode of a cell, that is known as cell potential. The other name of cell potential is EMF, electromotive force. Okay. So for mathematically, E cell is the symbol of cell potential, and E cell is equals to E cathode minus E anode. This is the first mathematical formula for E cell, E cathode minus E anode. And now we can use oxidation potential as well as reduction potential, but at this level in this chapter we will only use reduction potential for the calculation of cell potential. So we applied this formula E cathode minus E anode when we are using reduction potential value for cathode as well as anode. If we use oxidation potential for anode and reduction potential for cathode, this formula will be converted into E cell is equals to E cathode plus E anode. And when we use oxidation potential for both the electrodes, the formula will becomes E anode plus E cathode. So to avoid the confusion between the oxidation reduction potential, just keep this thing in your mind. E cell is equals to E cathode minus E anode, and we have to apply only here reduction potential. Now the same thing when we apply for standard condition, standard cell potential, standard cell potential. The symbol of standard cell potential is E standard cell, and meaning is same like that standard electrode potential means when the cell potential determined when the temperature is 298 Kelvin, pressure is 1 bar and the concentration of electrolytic solution is 1 molar. That is known as standard cell potential. And for calculation, the formula becomes like this: E standard cell is equals to E standard cathode minus E standard anode. And to explain this phenomena, suppose we want to determine the standard cell potential of Daniell cell. And in the Daniell cell we know very well, cathode is made of copper, so it will be Cu2 plus oblique Cu minus. Anode is made of zinc, so it will be Zn2 plus oblique Zn. Now the interesting thing is that, sir, if zinc is working as anode, here we should write the oxidation process, your dear friends, but because for both these two electrodes we are dealing with reduction potential, so that we have to use here reduction form, not oxidation. Okay, so the standard value of copper electrode, that comes 0.34 volt, and the standard reduction potential of zinc, that is minus 0.76 volt. So again this is 0.34 volt plus 0.76 volt. After doing the solution, the E standard cell for Daniell cell comes 1.1 volt. So in this manner we can calculate standard cell potential as well as cell potential.